Hey, it's OG Math Mosley, and today we're going to be going over the basics of solving linear equations. So let's get started. All right, so here we go. We're going to be solving linear equations today. Quick little joke. Dear algebra, please stop asking us to find your x. She's never coming back, and don't ask why. Oh, math jokes are so great. So first thing I want to stress is that a solution is the same as the equation being satisfied. You might see that term used in some math textbooks. Let's say what value satisfies this equation. Right? So we want to kind of make the connection between a solution and satisfied equation. Right? Finding a solution to any equation means to find the values, again, to satisfy the equation. More simply put, the solution will be the perfect number that provides the requested result, like the perfect match. Think of being satisfied. You haven't had too much or too little, but you've had just enough. Right? It's kind of like the Goldilocks and the three bears, right? One was too much, too little. One was just right. So we'll think of that idea. You don't want the number to be too big, too small. It should fit just right and be the perfect thing. So keeping on this theme, we'll consider this equation, x plus 2 equals 7. Right, if I replace x with 1, then I get 1 plus 2 equals 3, which is too small. Right? That value for x does not work. Right? If I replace x with 8, then I get 8 plus 2 equals 10, which is too large. Right? We're going to undershot, we overshot. However, if I replace x with 5, then I get 5 plus 2 equals 7, which is just right. And the equation has been satisfied. We found that one value. In this case, there is only one number that is just right, that number 5. There's nothing else I could put in place of x that would work and satisfy the equation. All right. We try to achieve this satisfaction through balance. Right? The most common method for algebraically solving equations is the balance method. In this method, you use identical operations on both sides of the equal sign of an equation. Using these operations, you manipulate the equation until you are left with x equals the solution. Let's use the balance method on our previous example. And we see here that we started with our x plus 2 equals 7. And we said x plus 2 minus 2 minus 2. So I'm subtracting 2 from each side of the equal sign, thus creating balance. Subtracting 2 from x plus 2 leaves me with just x. Subtracting 2 from 7 equals 5. And I found the solution, right? The same solution that I came to on the previous page. Right? 5 is that perfect number that perfectly satisfies the equation. All right. Now, one of the keys in this is going in reverse. Right? When solving equations, go in reverse order of operations around the variable. Right? The goal is to get that variable by itself and have it set equal to the number that perfectly satisfies the equation. Right? We use the reverse order of operations to do this. Right? Our normal order of operations, we start with parentheses, exponents. Square roots is technically part of exponents, so I wanted to include that. Multiplication and division, right? There's a couple different symbols we can use for multiplication and for division. With multiplication and division, we do whichever one comes first, right? As far as order goes. Neither one has a higher priority, going left to right, which one goes first. Then we have addition and subtraction. And again, whichever comes first as we work left to right through our equation. That's our normal order of operations. The reverse order of operations, we first do addition or subtraction around that variable. What can I add or subtract to get closer to having that variable by itself? Once again, we have to do whichever comes first. Then we move on to multiplication and division. And again, whichever comes first, whichever one, as I work towards that variable being by itself, comes first. Okay, then we would move on to exponents, and finally parentheses. Okay, we try to strip these things away in reverse order where we can. Okay. Now, let's look at a sample. Okay, we got our free sample here, using order of operations to simplify an expression. And I'll get back to the verbiage here. So we're starting with x squared plus 2 times 3 minus 6 divided by 2. Notice that there is no equal sign. All right? That's because this is an expression. It's just a set of numbers and operations that I can simplify by doing those operations and being left with either just the variable with a number or a number if possible. In this case, I have a variable, so I'm not going to be left with just a number. Right? So let's find the simplification of this. So we have to use order of operations. So it says do parentheses first. I can't do anything within the parentheses. I can't add 2 to x squared because I don't know what x is. All right. Then we move to exponents. I can't do anything with the squared because I don't know what x is. Multiplication and division going left to right. So this says I have x squared plus 2 times 3. All right, so I'm going to multiply each term inside the parentheses, because I couldn't combine them, by 3. All right, so we do times 3 to the 2, and times 3 to the x squared. All right, so that leaves me with 3x squared plus 6. Right? And then we drop in the rest of these things, minus 6 divided by 2. Right? The next thing, right, I did my multiplication. The next priority thing is division. So I have 6 divided by 2, which is the next operation. So I'll have 3x squared plus 6, 6 minus 6 divided by 2 is 3, so it's minus 3. Now, I can do addition or subtraction. So I have 3x squared plus 6 minus 3. I can do the 6 minus 3. I end with 3x squared plus 3. Right? This is as simplified as I can get this. All right? So at this stage, we are done with the simplification of this expression. I don't have it set equal to anything, so I can't solve it. I can't do any other operations on it anymore, so I'm done. Okay. Now let's look at an example where we're using reverse order of operations to solve an equation. We have the same equation, but now I have an equal sign and I'm equal to 8. Right? In this case, right, we have to strip everything away to be left with x equals something. All right? So we need to get this parentheses thing by itself. All right, but we do still need to kind of pay attention to the normal order of operations on the left-hand side, because I can simplify this first before solving. So essentially, we do the operations from this left-hand side and then swing into our reverse order of operations to strip everything away. So we do all of this, right? And we take this result and we're going to use that to solve. So we first need to simplify the left-hand side as much as we can, which we've done, and then we can solve. All right? So we simplify, then solve. So we'll start here now. We've already simplified, so we know it's 3x squared plus 3 equals 8. We subtract 3 from each side, because in reverse order, we have addition or subtraction, right? So I have to subtract the 3. The plus 3 minus 3 is 0. 8 minus 3 is 5. So we have 3x squared equals 5. And then we must move on to multiplication or division. In this case, we have 3 times x squared. So to reverse that, we do divided by 3 on each side. Because again, that leaves me closer to having x by itself. 3 divided by 3 is 1. I'm left with x squared equals 5/3. All right. And then we have to undo the exponent, which is the next part of the reverse order. To undo a squaring, we take a square root. And we have to do that to both sides. So we have x is equal to square root of 5/3, which we can leave it just like this, or we can grab our calculator and find the square root of 5/3, which is here. It's about 1.29. Approximately, if we round it to a couple decimal places. All right. Typically, you just leave it as the square root of 5/3 is okay, unless you needed that actual decimal representation for some reason. Okay. So this kind of shows the use of order of operations and then reverse order of operations to solve. Lastly, let's just do some extra examples just for funsies. All right. So let's start here with this first one. 5p minus 14 equals 8p plus 4. I have variables on both sides of the equal sign, so I need them on one side. So I'm actually going to do that first. I'm going to subtract 5p from each side. 5p minus 5p is 0, which leaves me with negative 14 equals 8 minus 5 is 3p plus 4. I'm going to subtract 4 from each side. Plus 4 minus 4 is 0. Negative 14 minus 14 is negative 18, which equals 3p. Divide each side by 3. 3 divided by 3 is 1. So leaves me with just p. Negative 18 divided by 3 is negative 6. And we're done. We've found the perfect solution again that satisfies our equation. Our next one here, we have negative, and then in parentheses 7 minus 4x equals 9. So first I want to simplify, which means I need to distribute this negative to what's in the parentheses. Right, so we have negative 1 times 7 and negative 1 times negative 4x. I end up with negative 7 plus 4x equals 9. I didn't do anything to the right-hand side, so the right-hand side doesn't change. Now I'll start my reverse order of operations, try to get closer to x by itself, and we add 7, because minus 7 plus 7 is 0. So we add 7 here. That leaves me with 4x equals 9 plus 7 is 16, divided by 4. Divided by 4, 4 divided by 4 is 1, so I'm left with 1x equals 16 divided by 4 is 4. And again, we've found our solution. All right. Last example here, we have 5n plus 34 equals negative 2 times, in parentheses, 1 minus 7n. So again, we want to simplify first. In this case, we need to simplify the right-hand side before we can get started. So we have negative 2 times 1 and negative 2 times negative 7n. The 5n plus 34 stays the same because I'm not doing anything to that side yet. Negative 2 times 1 is negative 2. Negative 2 times negative 7n is plus 14n. Okay, now I want my n's on one side and my numbers on the other. So I'm going to subtract 5n from each side. 5n minus 5n is 0, so I get left with 34 here, equals negative 2 plus 14n minus 5n. We'll have negative 2 plus 9n. We'll now add 2 to each side. Negative 2 plus 2 is 0. 34 plus 2 is 36, equals 9n. Divide each side by 9. 9 divided by 9 is 1. So I'll be left with n. 36 divided by 9 is 4. Because 9 times 4 is 36. And there again, we found our perfect solution. Okay? Now, the last step you should normally want to do is plug your solution back into the original equation to ensure that it worked out correctly. Right, so I'm going to demonstrate that on this middle one here, mostly because I have the most space left in that one. Right, so the way that's going to work out is we're going to replace everywhere I see x with a 4. So we'll have a negative 7 minus 4 times 4. Close all the parentheses. That's going to be equal to negative 7 minus 4 times 4 is 16. And then we have this negative 7 minus 16. Negative 9. Negative 1 times negative 9, positive 9. And our solution checked out. Okay. So again, you want to take that extra step, especially while you're still learning how to solve equations and solve linear equations, to check your solution. It's the best way to identify if you've made an error, see if it works. Right? And that's it. Thank you so much for watching. If you have any questions or comments, please email me or leave them in the comments. This is OG Math Mosley. I'll see you next time.